I'd like to welcome you all to the first event of the Stone Future series. Now, this will run across the autumn, winter, and into spring next year. And the series is brought to you by the Chartered Institute of Architectural Technologists, Scottish Ecological Design Association, Historic Environment Scotland, the Stone Federation of Great Britain, and the International Festival of Stone in Dundee 2026. Across the sessions, we'll explore heritage and history of stone, lessons from practice that inform, inspire, present practice. We'll look at the environmental and embodied carbon, the challenges of quarrying and processing stone, as well as the development potential to explore new opportunities with stone in the UK and how it can be integrated at projects at scales. And we'll also be looking at sort of inspiring innovation case studies, what people are doing and how engineers are reimagining this within contemporary architecture. So just the background of these sessions, they're to be short, sharp, really just introductions to showcase what's going on with the material. And we've got an incredible list of speakers presenting across the series. So just as a final reminder, we'd like you to ask to turn off all your microphones. And similarly, this is being recorded. So if you don't wish to be recorded, please turn your cameras off. We'd also encourage you all to use the chat function for any questions or points that you wish to make to the speakers, and we'll try and work through as many of them as we can at the end. So finally, without further ado, we have two fantastic speakers to introduce that are going to talk for around 20 minutes each on the development potential, and this is really going to kickstart this series off, the Stone Future. So we've got Charlotte Taylor. Charlotte's currently completing her PhD in the Department of Civil Engineering and Architecture at the University of Bath. Her research investigates the UK construction sector's zero emissions resource pool in fossil-free economy to 2050, with a focus on structural stone and load-bearing straw bale and the structural reuse of construction materials. And Charlotte will be followed by Imogen Shaw. Imogen's a building stone scientist based at the British Geological Survey in Edinburgh. She provides scientific expertise on the properties context of Scotland's current historic building stones to a wide range of stakeholders, including conservation professionals, quarry operators, and local government. So we'll start with Charlotte Taylor first, who'll do 20 minutes, and then followed by Imogen, and then followed by a quick 10 minutes Q&A. So I'm going to stop sharing my screen and ask Charlotte to start sharing hers.
Thank you. Okay, great. Let me just share that slideshow mode. Okay, can everyone, is that okay, Graham?
Yep, we can see that.
Yeah,
perfect.
Okay, perfect. Okay, so thanks for that introduction. Yeah, I'm Charlotte, and I'm finishing my PhD at the moment. I thought I'd just quickly talk about why I started getting into construction material research. I actually lived in Glasgow for 7 years, and I was working as a structural engineer there. And I felt quite frustrated about like the design I was doing with materials, but the kind of lack of awareness of the landscapes that these materials were coming from. So I started volunteering in Dunbar at a charity project called The Ridge, where they were developing a construction skills heritage centre. And one of the materials they were using to repair one of the buildings was stone. So I was kind of volunteering, doing some material mapping of the stone, and kind of connecting the dots between the trainees and the landscapes that these materials were coming from. And I really enjoyed this kind of discourse between landscapes, materials, construction, design. So I started my PhD, which is called Ecologically Constrained Building Design. What can we build from the zero emissions resource pool? And fundamentally, it kind of imagines that or hypothesizes that to reach zero emissions in the UK by 2050, we have to stop using fossil fuels today. And if we were to do that, kind of what construction materials could we still produce? And so it says, like, to 2050, we need to reduce the materials that are incompatible with fossil-free production, whilst kind of increasing those materials which are compatible, all the while kind of reducing resource use overall. So, for example, if we look at concrete, like, is concrete compatible with fossil-free production? We see that it's not, because during cement production, there's process emissions released, and the current decarbonisation strategies for concrete either still rely on fossil fuels or unlikely to be ready at scale by 2050. These are some of them. So the only kind of option to use concrete is like the direct reuse. Stone, on the other hand, when we look at its production process, we see that every stage along its production and manufacturing can be electrified, and therefore is compatible with fossil-free production, which is great. But yeah, do we have enough stone at scale? What is like the history and legacy of stone use in the UK? It's been used for thousands of years in construction, like Canterbury Cathedral, built in like kind of 600 AD. And then St Paul's Cathedral, obviously built from limestone from Portland. And then also like whole cities in the UK built from stone as well, like in Bath, Glasgow. But then today, because of like in the late 19th and 20th century, innovations in steel and concrete being much quicker, much faster, much more desirable, we now see stone primarily in like facade systems where you have very thin sheet tiles, which are kind of clipped on to steel frames often, creating very complex structures basically, that involve a lot of energy in their production. At the same time, like there is a resurgence now and kind of excitement, I guess, in the use of load-bearing stone in construction that's starting to become more popular. Like we're seeing this kind of plan for a block 24 flats, I think it's 10 stories, by Group Work Architects. And I think this is in Paris. There'll be like 58 apartments built out of load-bearing stone and wood and hemp. And then the kind of famous 15 Clerkenwell Close is a classic example of load-bearing stone used as well in a kind of modern context. And the Stone Collective have created some quite nice drawings of like modern examples of stone typologies used in a load-bearing context. And also in the UK, we kind of have a history of quarrying, building stone, so like cut dimension stone used for load-bearing context. This is Winspit down in Dorset. Don't know if anyone knows it. It's by my favourite pub, Square and Compass. Yeah, and so there is the kind of, this is just one example, but there are like many building stone quarries all over the UK. But today we actually import around 80% of our dimension stone, either as raw blocks or as pre-processed products. And whilst there used to be over, I think, 3,000 dimension stone quarries in the UK, there's only around 400 today producing. So like the UK's total output of dimension stone is around 1 million tons, which is in quite big contrast to the like nearly 200 million tons of crushed rock aggregates that are produced every year. And this is also surprising when 98% of major cities in the UK are within 80 kilometers of a stone quarry, we found in our study. So yeah, these findings and understanding of like potential for load-bearing stone in the UK in conjunction with its history and compatibility with zero emissions made like this research question kind of arise, which is if the UK government decided to meet construction demand for the structure of 300,000 new homes a year with load-bearing stone tomorrow, what barriers would be faced and where the opportunities lie in the rapid scaling of this sector? So I'm now going to speak about a research paper that was recently published which was like the output of a research project that happened last year with people at the University of Bath, some fellow researchers. And yeah, I'd like to say that this is just, I don't know everything about kind of the scale-up potential of load-bearing stone. So this is, I guess, a step in the right direction, but there's still a lot of future work. So yeah. We chose our approach to answering this question, or attempting to answer this question, was to use interviews. So we interviewed 19 different building stone and aggregate quarries across the UK and Europe, involving site visits and online interviews as well. And yeah, there was 12 UK participants and 7 non-UK participants from international countries and in Europe, and yeah, a mixture of dimension stone and aggregate businesses. So I'm just going to talk about our main, like the findings I think are most interesting. The total stone resource, the underutilization of stone, the decarbonisation potential of stone, the labour requirements for scaling up, and the market demand and cost of load-bearing stone. So I think Imogen will speak a bit more to this, but we have in the UK widely available limestone and sandstone and igneous stone kind of building stone deposits. And but we were really interested in finding out whether where the quarries currently are is the kind of resource and reserves of load-bearing stone limiting to scaling up. And we found out basically that no, it's not. That whilst, as you can see from this graph, there's like a kind of limit on the permitted reserves quarry businesses might have, that these are much smaller than the total reserves. And so it's just a matter of needing to apply for like permitted area expansion, which can take a long time. So we found that often the businesses were saying that they needed the processes to be streamlined, and like planning approval should be kind of be made a lot quicker so that to encourage scaling up. I'm also just going to read out some of the quotes from the interviews because I think they're quite interesting. I don't want to lose their nuance. So one participant said, the largest quarry area with permission to extract stone is the 75-acre site. It has been operating since 1980 and we've only worked across 8 acres in that time. Another said, operations could continue for another 1,000 years at the current extraction rate. So that just kind of gives you an idea of the scale of stone reserves and kind of like basically that the permitted reserves and total reserves are not the limiting factor. We were also really interested in the development potential of aggregate quarries because aggregates in the UK already, or the businesses already operate at economies of scale. They often have very developed transport links and have already got planning approval for the extraction of stone. So we were wondering if some of this stone could be actually cut out in raw block form rather than kind of cut or blasted and crushed. Yeah, so one participant said, we have an operation of 100 aggregate quarries and 20% of these historically produced dimension stone products until 10 to 15 years ago. The aggregate quarry was producing building stone from limestone and roofing slate. They partly switched due to demand and partly workforce. And another said, the outcrops have previously been the source of large blocks. However, extraction has ceased as the process is quite labour intensive and therefore expensive. Dimension stone is not our primary concern yet, but I believe it will shortly be the main purpose of the quarry once we have obtained permission to extend beyond the existing bounds. Dimension stone can be sold at a higher rate per tonne, and I'm intending to separate the extraction of aggregates and block material as the quarry develops. I'll summarize this one. So there was a general like enthusiasm and for aggregate quarries to adapt basically to dimension stone production, but there were some doubts, I guess, around the investment that would be needed to transition in terms of needing different machinery, and also doubts around there being actually any demand for dimension stone. And then also some more technical things like when the aggregate quarry has been used to blasting, that can cause fractures in neighbouring rocks. So there would need to be more also investment in testing. But still, it was quite interesting to hear the potential of this adaptation. Yeah, so another thing that we wanted to investigate was the utilization of stone in terms of how much stone which is extracted out of the rock face has load-bearing potential, and then how much of it actually gets used in different types of products. Yeah, so we found that actually out of the participants that responded, around 61% of rock that's extracted from the face could have or like has load-bearing capacity. But this was in like quite stark contrast to also finding that an average of around 71% of total product sales are for non-load-bearing uses. So yeah, I guess most of the rock has load-bearing capacity, but it's not used in a load-bearing capacity when it's sold or used in construction. And it's mainly used in kind of like walling products or facade products. Yeah, so this diagram you can kind of see how stone starts off as maybe like extracted as a raw block, but then kind of cascades into the more you process it into slabs, into walling products, into ornamental products. This is what's typically happening at the moment. So we did quite a lot of site visits, which was fun, going down different mines to try and understand the kind of scale of rock or stone that is extracted and maybe wasted. A lot of the quarry operators don't like the word waste because they believe that there isn't any, because if they're not using it, they crush it into aggregates. But I guess waste for us is rock or stone that doesn't reach its like load-bearing potential by getting utilized in the bone construction. Yeah, so we found that like stone waste arises primarily from inefficient extraction techniques. So when there's like, if you're specifying too deep blocks and then the beds maybe you can't utilize all of that from just the way the bedrock is, then a lot of stone gets wasted that way. And also one of the main sources of waste is architectural preference. So when blocks have kind of shelly consistency or the kind of aesthetic variation, they're kind of deemed unloved or unusable. And yeah, we were seeing a lot of sites like this of kind of, yeah, huge, almost graveyards of waste blocks. This is like, yeah, from the extraction stage. And then there's also quite a lot of waste which is produced during the processing stage. Mainly because of the milling into fine tiles. So for example, when you're cutting a 20 mil tile, this can actually result in around 40% material loss. At the same time as also consuming more energy.
Just a 5-minute warning.
Oh, really? Okay. Yeah. So I'm just going to, yeah, this is probably one of our really big finding, I think, was how many of the participants were reporting like the potential for use as load bearing, but the architect's preference for visual kind of like uniformity resulting in a lot of waste. Yeah, I'm just going to skip through this a bit. There is kind of quite high decarbonisation potential for stone, basically, with a lot of development at the moment in electric machinery. And also was very excited the other day, went to visit the Pay Stonework in Stroud, where they're kind of reusing, finding ways to reuse stone by like dismantling whole buildings and use it in load-bearing capacity. And there's some quite interesting research at the moment, which is also looking at ways of digitally reusing stone, or digitally like finding ways to reuse stone and post-tensioning it to make new columns from my stone. So that's quite exciting. Another key finding for one of the main barriers is the labourer shortage in the UK. So if we need to scale up to meet construction demand, there's obviously going to need to be a scale up of a coordinated workforce. And we found that amongst the survey participants of the study, the availability and the cost of labour pose one of the main bottlenecks to scaling up operations. Historically, in the UK, the greater number of stone quarries would have meant that there was an increased demand for education in stonemasonry and on-site skills training. But today, stonemasonry is included on the UK Heritage Craft Red List, meaning it is at risk of disappearing, because although it's still needed, not enough people teach it. And many businesses prefer to train people in-house due to specialised knowledge required. But the lack of investment in upskilling local people in apprenticeships prevents them from scaling up their workforce currently. So this creates a challenge where the construction industry will require the equivalent of 350,000 new roles to be created by 2028, in line with the UK government's commitment to net zero greenhouse gas emissions by 2050. One pathway would be to automate some processes, for example, using like CNC machines, but a lot of finishes still have to be done manually, depending on the rock type and how bespoke the product is. So therefore, future supply should comprise a combination of standardized products, such as stone bricks, but also more bespoke structural stone elements supported by well-funded training and apprenticeship schemes for all stakeholders in the supply chain, including stonemasons, quarry operators, truck drivers, contractors, surveyors, and architects and engineers. So some of the things people were saying is the primary bottleneck affecting approximately 90% of operations will likely be the workforce across all levels, including extraction, transformation, and installation. Or quarries are not generally nice conditions to work in, not attractive to a lot of people in the modern day. So we're noticing a decline in skilled labour. It's not a major problem at the moment, but it's likely to become an issue in the future. And the government have brought in various grants that give money towards apprenticeships, but these only cover a small fraction of the cost, limiting the number of people we can afford to take on. Increased funding like this would help. I'm just going to skip that one. Yeah, and finally, the market demand and cost of load-bearing stone. So we found that there's really bad data on the cost of stone. It's often based on like ceramic brick masonry, and the range of costs for blocks varies so much because of the level of processing. So kind of a raw block can actually be quite a lot cheaper sometimes than concrete even sometimes, but it can also be like, extremely expensive depending on the level of processing. And yeah, several participants suggested that structural stone could be 60 to 70% cheaper if stone was used in its like raw block or less processed form. We also found that labour was ranked around like the highest cost. And people were saying things like cost could be much cheaper if increased market demand. Currently, stone is a vanity cover for buildings. If you use load-bearing stone and get rid of steel and concrete, the cost could drop to 60, 70%. Currently, there is no demand for load-bearing stone in terms of orders, but lots of architects are excited by it. So we need to encourage the middle part of the interest, the main contractors. So laws and local regulations can specify the minimum amount of emissions-free materials in building projects to secure the demand and allow local producers to step up on the supply side. That would could reduce costs. And also public institutions and clients could use their procurement policies to create demand for structural stone products in buildings and infrastructure. That could reduce costs. We've also found that due to the energy-intensive mobilization requirements of heavy stones, the transportation distance can greatly impact the total cost and embodied emissions of structural stone production. So yeah, obviously it's very key to try and build on local supply chains of stone to keep costs down and to keep transport emissions down. And yeah, so together these challenges expose the complex conditions shaping the scale-up of structural stone in the UK. The material's promise lies not only in its geological abundance, but also in how quarries, architects, engineers, and policymakers might reconfigure their relationships. Unlocking its low emissions potential requires rethinking value beyond aesthetics, investing in new forms of labour and mechanisation, and embedding load-bearing stone within cultural, technical and regulatory frameworks that together determine how holistic zero emissions futures the built environment can sustain. So this work was just an initial step in assessing the scale-up potential of load-bearing stone in the UK, but future research is needed into other critical aspects of stone use in the UK, including resistance to weathering, fire, and also I really think that this kind of connection between the labour and workforce upskilling and stone is a project that I'm really excited by, and I think, yeah, needs a lot of work. So yeah, increased uptake will depend not only on technical performance, but also on building greater confidence amongst designers, clients, insurers and contractors through improved knowledge, familiarity and built precedent. Yeah, so I think that's me done now.
Okay, thanks very much, Charlotte. That was really interesting, and we'll drop a link to the paper that Charlotte mentioned in the chat because it's really quite interesting.
Yeah.
So thanks very much, Charlotte. And
Okay.
our next speaker is Imogen Shaw. So Imogen from BGS, could you share your presentation, Imogen?
Yeah, I'll just get it up. There we go. Is that sharing now? I put it into present. Is that good, Graham?
Yeah, that's perfect. Thank you.
Okay, perfect. Cool. Well, yeah, so I'm a geologist by background. So I kind of came into this problem really looking at the geological resources that we've got in the UK and particularly in Scotland, and how, you know, the different geological materials that we have in the country have been used for building stone in the past, and then kind of really we're left with a great question of all of these materials have been used in the past, but they're not being used anymore. So I'll just kind of going to start the talk with a bit of the geological context and the historical context. This is a map of the bedrock geology of Scotland. It's basically just to show that we have a huge range of stone types, you know, spanning sandstones, flagstones, igneous metamorphic rocks like granites, slates. We've not got much limestone in Scotland, but you've got some in England, and basically every single one of these different stone types has been used in the past. We've got a map on the left of building stone quarries, and we've got, these are just the ones that we have written record of, and they're over 3,700. And so really stone has been quarried all over the country for different uses. This just shows the kind of broken down the geology into different stone types. And each of these different stone types, because it's got a slightly different geological property, it tends to be used in slightly different ways. So granites and dolerites, winds, kind of igneous rocks are usually very, very hard, not very porous. It makes them very, very durable materials, but sometimes quite difficult to work in ornate ways. So they're often used, so it gives you kind of grand, imposing buildings in Aberdeen, which are kind of usually just flat facades. They're often used as sets and things for paving. Sandstone, on the other hand, is much easier to work. So in the central belt of Scotland, where you've got a lot of sandstone that outcrops and has been quarried, you have very beautifully carved sandstone buildings. Flagstones are actually geologically quite similar to sandstones. They're both sedimentary rocks, but flagstones have basically been laid down in very distinct layers, which means they split into nice flat slabs, which makes them good for paving. And slates are metamorphic rocks, and effectively they're very, very impermeable, and they split very thinly, which means, you know, we've used them on roofs all over because they're perfect. They shed the water, they don't absorb it, and you can split them quite thin, so they don't put too much load on your roof. And so this slide just shows the kind of like different characters you get from building with these different materials. In the past, it was quite expensive and difficult to transport like huge amounts of stone you know, long distances. And so it means different areas of Scotland have very different kind of like vernacular characters. Mostly you can see the kind of sandstone buildings at the bottom of Edinburgh and Glasgow are very ornate. You've got Orkney, which is mostly flagstones, and they've been used not only as paving but to build up. So, you know, out of necessity in the past, we really had you know, a culture of using what was there. And this is a slightly more modern building, but not like massively modern. But we're seeing here rocks from all over Scotland have been used for different purposes, you know, to create basically the building and the whole streetscape. You've got slate on the roof, you've got sandstone, equally limestone is often used in facades of buildings, and then you've got a flagstone on the street, on the pavement, and then a wind-sets on the road. So this is like a type example of, you're in Scotland, all of these rocks, all of these building stones can be quarried in the country, but they're not. So this is the map again of the historic building stone quarries in Scotland, next to the quarries we've got today. So we, you know, have 3,721 building stone quarries recorded, and only 17 of those are producing building stone in Scotland today, and not all of those are producing stone regularly. Some of them kind of, you know, produce stone as and when. And that means that, you know, if we go back to this great range of stone types here, most of these are no longer being produced, which is, it's a problem for heritage. It's also a problem for, you know, creating new builds that are in keeping with the local character that you've got. And it's just a kind of problem for the stone industry, because we are using less stone, kind of, as Charlotte touched upon. We've kind of moved into using concrete and brick and steel and things. But we're also still using stone, but most of it is coming from overseas, and that's a lot of money leaving the UK economy, and also has big carbon implications. So this slide just kind of goes through a load of different reasons why it would be important to use local stone. So the graph shows the embodied carbon in your stone. So stone is kind of naturally quite a low carbon material, but if you're transporting it particularly from overseas, that's the step that's ringed in red. It skyrockets. The green is a stone that's been imported from India, compared to the blue, which you can't even see, which was a stone, you know, theoretically 6 miles or something from the site, and then the orange was something kind of in the middle. You also, in the bottom left, you've got kind of heritage issues. Often, you know, the stone's porosity and its other material properties are really important when you're doing building repairs. And if you can't get something similar anymore, sometimes you end up with kind of ineffective, poor repairs being made to historically significant buildings, and that can increase decay. It's also, I touched on before, you've got a huge amount of money leaving the economy. So this is an example of the Edinburgh Trams project, which used £1 million worth of Chinese granite. You know, imagine that the businesses that could support if it was coming from the UK. And yeah, bottom right is just a kind of like aesthetic issue of slate in Scotland. It's a Scottish roof on the left hand side of that picture, and it's a Spanish slate roof on the right. And you know, it really changes the character of your streetscape, even if you're not dealing directly with heritage buildings. So we really wanted to look at, okay, you know, this is a problem, and there are some identified kind of benefits to using UK building stone, but we've only got 17 quarries in Scotland and a few more in England and Wales and Northern Ireland, and so it would be great to bring those back, but realistically, you can only kind of support a building stone enterprise if there's a market for the stone. So we wanted to have a look at that first. Charlotte touched on it. The data is really, really patchy, particularly for building stone production in the UK. But we had a look at imports and exports and found some kind of interesting things. It's basically that imported stone is increasing kind of both in terms of mass and value that we're importing every year. There's a breakdown of stone types by import, but also critically, like, not only are we importing more and more stone, it's becoming more expensive per ton over all the stone types we looked at. So that's what this kind of set of 4 graphs is showing. It's compared to 2015. Even adjusted for inflation, the price of imported stone is really increasing, and that's significant because if that trend continues, then maybe even by a cost argument, you know, British local stone is going to become more attractive to procurers. And this, again, these are big price ranges, but these are the approximate price ranges we managed to pull out of the trade statistics for different stone types. And so I suppose if you want to be like cynical about it, those are the kind of price ranges that stone suppliers need to be aiming for if they want to compete with imported stone. And so it's assessing whether that's feasible or not. So we looked at the market and kind of established that maybe there is potential for local stone to kind of take up more of the building stone market than it is currently. So then we needed to look at basically where do we get the stone from, because we've got 3,700 disused quarries in Scotland, and a lot of them are now landfills, or they're flooded, or they're really overgrown, and no one can dedicate the resources to trying to reopen all of them. So it's about kind of like directing your efforts to the where there could be maximum gain. So we wanted to look at which stone types would be the most beneficial, and basically which quarries would be the quickest wins to bring them back in. So to assess which stone types were the most important, we looked at the stone's historic quarrying scale. So we kind of looked at all the historic quarries that we have records of, how big they were, and, you know, summed that over stone type. The historic reach of the stone, so if it had been used locally or nationally or internationally. And those two things really tell you not only about the historic significance of the stone, which is important in a heritage context, and kind of telling you how many heritage buildings or conservation areas are likely to be wanting this stone, but also it gives you an indication that if a stone was very popular in the past, it is more likely to be popular again today. So from that, we identified 37 out of 198 different building stones that were the kind of most historically significant. And then once we'd got that, we had a look at the individual quarries and sources that were supplying them. We ruled out anything that had significant competition from UK producers already, because we don't need to be stimulating competition in a UK market. We looked at the accessibility of the resource, as in kind of what the ground conditions are around it. Anything that had been sterilised with landfill or buildings on top of it was, you know, ruled out. And we had a look at settings, because even if a quarry is kind of reasonably exposed, if it's in a built-up area, it would be a lot more difficult to reopen. So then we combined those and we got a set of, for the most important historic stones, you then have 170 quarries that have supplied those. and kind of have the most development potential. And that's for all types of stone that has been used in Scotland. So sandstone, flagstone, granite, slate. And we turned these into fact sheets that had, you know, the list of all the different stones and, you know, the quarries that they're on and a little bit about the market and things. And yeah, if you're interested, you can read more in the report. There's plenty. So just to finish off, I wanted to kind of touch more deeply on one of the stones that we identified as being the most historically significant, and a kind of quarry that has been closed for about 60 years but has significant potential now to reopen and is really exciting, as just a little case study that this kind of thing can actually be pulled off. So Scottish slate, again, all types of Scottish slate that have been quarried in the past actually were deemed historically significant. There are three main types. There's West Highland slate, Highland border slate, and Macduff slate. And here's the picture again. You know, the critical thing about all of these types of Scottish slate is none of them have been quarried in about 60 years. So we're seeing increasing numbers of slate roofs needing repaired or completely re-roofed, and there's no appropriate material really to repair them with. And so you've got a significant supply issue. UK slate production as a whole, not even just in Scotland, has been decreasing, but slate imports are increasing all the time, and the price of the slate is increasing. And so there's this huge market for slate, and you can't get an appropriate material in Scotland, and we really need it. And so it's kind of it's looking good. This is a photo that Graham took, just of a pallet of Spanish slate being shipped over, and you can see a Scottish slate quarry in the background. So that's kind of what we're doing at the moment. But Cullerpool, I'll go back. Cullerpool quarry quarried West Highland slate, which is the pink on the map. It's just one of the islands out on the west, and was, you know, that was like the big industry of the island at the time, and, you know, known as the islands that roofed the world. So it was a really, really significant exporter internationally of this really high quality slate roofing material. So there were kind of like deeper investigations done into this. The important thing about the study that we'd done for development potential is it's a really kind of broad starting point. So any individual quarries that are identified will need to have like greater geological investigation and things. There's a lot more paperwork to do, but it's a start. And so, you know, basically the more paperwork has been done at Ling, and it found that, yeah, there was actually like significant resource left in the quarries, and it was possible to, you know, reopen them, and also kind of combined with, you know, how brilliant it would be for everyone to have a source of Scottish slate. It would also be really good for the village that's there, because they're kind of suffering from advancing coastal erosion, and in the past the waste from the quarry was just tipped directly onto the beach in a kind of type of coastal nourishment.
Just a couple of minutes, Imogen.
Okay, cool.
Yep.
So yeah, you had this really kind of like sustainable thing, that there were families on the island, there were people employed, the beach was constantly being nourished, and now the industry's kind of collapsed, the island is depopulating, the sea's advancing, and all of these things could conveniently kind of be solved by or maybe not solved, but, you know, improved by the resumption of a slate quarrying industry. And so the exciting news here really is that they've got planning permission and funding to resume a small slate quarry on the Isle of Ling. I think it's going out to tender soon, and planned production to start kind of trial next year. So it's just a nice little case study that when the stars align, this really is a feasible thing to do, and hopefully can be done in other places too. So yeah, just to wrap up, like, these are the main messages of the talk, is that Scotland has a huge variety of natural stone resources that have been used in all types of buildings for thousands of years. And there is still a demand for natural stone, but we're not meeting it with stone from the UK, which is a shame, because there are all sorts of benefits that could be brought by meeting it that way. And we found that the Scottish stone industry has potential to grow if it's kind of supported in the right way, but crucially, kind of to realise that potential, there needs to be investment, and there needs to be support on the specifiers side, and things like that. And so it's very exciting to see architects and people more interested in designing with stone too. So yeah, I think that's me.
Okay, thanks, Imogen. Yes, and if you're on your travels in Oban, go and visit Ling. It's a wonderful place, and it's starting to get very real with a potential slate quarry to be opened. So we're just going to go straight to questions, and I'm going to ask very quickly the first question. So this is to both of you. If you just give a sort of very quick one-liner. We have this fantastic material beneath our feet that we're currently importing over 80% of. So what do we need to do as specifiers, designers, to get Indigenous stone suppliers a bigger piece of the pie here? Because we don't need to grow the market, we just need to get Indigenous stone in front of the right people. So what would be your one key action that you think would help get support this?
I would say if you're working on a project, then find out what your local quarry is. Go and visit it, see what the range of stone there is they supply, and then start from there. Yeah.
Okay, Imogen?
Yeah, I would agree. I think it's really important to work with the stone that's available, and so kind of, yeah, maybe not being so strict on. I'm just trying to phrase this. I think a big challenge of the natural stone industry is, as Charlotte said, people are very specific about what they want, and accepting the natural variability of stone would go a long way to improving the use of it. And I think also, writing your specifications in such a way that it benefits the local stone, and working with the suppliers. I think it all kind of comes hand in hand.
Okay, so we've got Rob Latimer here, who's come in and said, government, industry, academic interest, who is best placed to solve the classic chicken and egg problem that we have? We won't generate consistent demand at scale without local production, and yet we need that demand before it becomes commercially available. So this is kind of, I think, really what Charlotte talked a wee bit about in terms of decarbonising our construction materials. So do you want to come in with anything there?
Yeah, I would say that as much as individual architects or engineers could be specifying stone, obviously to make an impact at scale, it would be really beneficial, I think, if the UK had some sort of policy or regulation quite similar to what they have in France, where I think it's all public buildings should be composed of 50% bio-based materials. So I think that's kind of charting for timber and other kind of materials that can sequester carbon, but I think some sort of policy where 50% of materials should be compatible with fossil-free production, for example. If you're having a policy like that, then yeah, that would be the chicken or the egg. I'm not sure, but okay. Yeah, I would say some sort of regulation like that would be really important.
Okay. So the next question, Neil McAllister. We keep being told that architects demand perfect quality stone leads to increased waste. I've never been offered any different levels of quality. The selection has already been made by the time it gets to the supplier. Some projects need flawless quality, but there are many times where a more characterful stone would be acceptable or even desirable if it was offered. I'm going to ask Imogen that. So, stone's a natural material.
Oh.
We're demanding too much. Because Neil says we're not demanding too much. We need to get these options. So
yeah, I don't know. I have to say I'm not sure why or kind of where the problem lies there then if different levels of quality are not being offered. I know definitely at Denvind, off the top of my head, at Peterlee Quarry, the different qualities of stone are produced into different materials for different uses. The best quality stone is sawn, and then other stone is cropped. And so if the selection is being made in the quarry for only the most flawless stone, then perhaps we need to talk to the quarry operators.
Yeah,
I would just say that the architects also are used to like kind of the catalogue logics of like, having a book to look through with the different profiles of stone, and then the quarry respond to that by giving their like best stone. But I think there are a few quarries, like I know Albion is now including their like Shelley stone in their catalogue, so that would be something you would be offered and see.
Yes, so we need to kind of start talking to the stone suppliers then, the quarry operators. Okay, so here's one for Charlotte. I may have missed the mention of this, but I've seen some discussion recently about the possibilities of large pre-cut structural stone modules, such as in 15 Clerkenwell Close. Is that something you've explored as part of your work, and do you see this as a likely viable and scalable approach?
The short answer is no. I haven't explored like the structurally the kind of potential of pre-tensioning, post-tensioning stone, but I do think that it is scalable. I think that Steve Webb is doing a lot of research into this with Aman Taha and the Stonemasonry Company, and I feel like it's a very good use of stone, because they're keeping all they're not milling it into kind of smooth sides. They're utilizing more of the stone, and the post-tensioning means you can use different sizes and shapes of stone. It's just, I think the scale-up barrier maybe would be again about labor there. It's like who's doing the work. Yeah.
Yeah, I know we've got one of our speakers later in the series, Juliana, talking about post-tensioning stone as well, so that will be towards the end. Christina Emberg, how is Link being powered? Is it fossil fuel or electric? Well, it'll be electric. I can answer that one. And Alex Little, how do we get contractors to change their minds about how to build? When most tier 1 contractors build in steel because they have always built in steel, and over their dead bodies will they stop building in steel? So I'm going to pass that over to both of you. Do you want to start with that one, Imogen?
I can try and start. I think, again, it's a little bit chicken and egg, but it's really helpful to kind of shout about where not building in steel has been a big success. More awareness of the fact that this is a viable option and not just like some guy's pipe dream. That would be my first step. I don't know if Charlotte has any other ideas.
Yeah, I feel like there is a job that needs to be created of kind of tying all the stakeholders in this stone supply chain together, from the contractor to the researcher to the quarry person. And once those relationships start to be kind of made more solid, then hopefully also the practice of design and building will change. I think there's still missing links that need to be strengthened.
Okay, so this is from David Wilson, which Imogen touched on a wee bit in her talk. Have the economics of any quarry that might potentially be opened or reopened been done to prove that these are financially viable? Well, we're seeing a lot of cost increase with imported stone.
Yeah, I think to to answer that, I'm not aware of any specific quarry having, you know, the specific economics of that stone kind of being analysed, because it's so difficult to put an exact number on it. I mean, even, you know, we've seen that there's a great kind of price range that stone can be sold for, and it's sometimes even within a single quarry, it's quite difficult to predict what sizes of stone and what kind of quality and what finishes and all the different things that affect how much you can sell a block for. It can be quite difficult to predict. So yeah, I think the economics have been done in a kind of broad sense. And if imported stone is getting more expensive, then it looks like it's kind of going in the right direction for UK stone suppliers, but there is always an element of risk.
Yeah, I'd agree. I don't know if Graham want to.
I think Graham maybe froze. There's another
Okay.
couple of questions, and there's another couple of questions in the chat. So there was one early one for Charlotte from Joe Snell. All of the flintstone used in Kensal housing facades from the 70s, was that stone mined from the UK or also imported?
I believe that stone was mined from the UK, from kind of south of England. I don't know if Imogen, you're aware of that.
Yeah, again, I don't know, like I've not seen any specific like reference to it, but that would be my guess. I would imagine it was mined in the UK.
And another question from May Fisher. Do you see that the main demand for stone is in repairs of historic buildings, or is there many new build projects specifying stone? Architectural education seems to be very focused on timber and bio-based materials.
I would say by far the bigger market for stone is new build projects. And that's,
Yeah, we found that actually from our study.
Yeah, in the sense of buildings and streetscapes and kind of like public realm works. Usually repairs to historic buildings are kind of like single blocks or a few blocks to a building.
Yeah, we found, I think it was like 50% of quarry businesses said it was their stone was going to new builds, and there was around 20% to landscaping, 20% historic.
Amazing. I'm very aware of time.
Yep.
It's just 2 o'clock and Graham's back, so I'll hand over to Graham.
Sorry about that. For some reason, my internet kicked me off and I panicked. So yeah, so I think we've just hit 2 o'clock. So there's one last question and then we'll wrap it up. Oh, I take it that was the May Fisher. You've just answered that one?
Yep, we've done that.
Yep.
Okay, right. Well, perfectly. And that's us that's us finished for the day. And apologies for my internet going down at the very death there. So just to let everyone know, that ends the first talk of the Stone Futures, and thanks again to our speakers Charlotte and Imogen. They were great talks, really sets the series up for us now. The next talk is on Monday the 3rd of November, where we will meet Pierre Bidot from the Stone Collective and Marcus Payne from Hutton Stone, who will be presenting on specifying stone. So please do sign up for the next talk on the 3rd of November at the same time, 1 o'clock, and we look forward to seeing you all in a month's time. Okay, thank you.
Thanks very much, everyone, for listening.
Thanks, everyone.